Okay, so let's talk a little bit more about cpctc. Let's give another example of how, once we can prove some triangle congruent, that we can then prove all the parts that go along with that congruent. So with that in mind, let's go ahead and let's start here. Given. So we have statements and reasons, and we have that AC is congruent to CD, and that is given. AC congruent to CD, given. Then we also have EC is congruent to CB. That is also given. Now the nice thing is we have one set of sides here. We have another set of sides here. What we need is we need some angles, or we need some sides to really start proving this triangle. So here we go. In this case, what else can I say about getting these lines parallel? Now you say, well, why don't I just say that this angle up here is congruent to this angle down here? Because if this angle here and this angle here, they're alternate interior angles. That's true. They are alternate interior angles, but we can't say that these two angles are the same because we don't know that these two lines are parallel. That's what we're trying to prove. And you can't say that because they're parallel, these are congruent, and we have no other reason to say they're congruent. So what angle can I get between the top triangle and the bottom triangle to help me prove these triangles? Well, how about this angle here and this angle here? Let's go with angle ACB is congruent to angle. Now, ACB, I went down the single, back up the double, so I'm going to go up the single and down the double. DCE by vertical angles. Now, if those are already vertical angles, I can say congruent, congruent, and now I have a set of angles that I can also use. That's enough to make a triangle because I have a side, an angle, and a side, an angle, and a side. So I can say triangle ACB is congruent to triangle DCE by side, angle, side. Now you say, so what? I want to prove lines are parallel. Well, now that I know this triangle and this triangle are congruent, what's true about this side up here, this side over here? Well, they're not parallel, but they could be congruent. We also know that in this particular case, this angle right up here and this angle right down here are now congruent because angle BAC is congruent to angle, so BAC, so I went over and back, EDC. Now, in this case, you'd say alternate interior, but remember, the lines aren't parallel yet. We can't say that. What I can say is because the triangles are the same, D and A happen to be corresponding parts and triangles that are already proved congruent. So by cpctc, they're congruent. Now, if those angles are congruent, then what must be the case? If these angles are congruent, then AB must be parallel to ED by alternate interior angles. And here's why. If alternate interior angles are congruent, then lines are parallel. Now, that's one thing we could say, and that gets our proof accomplished. But there are a lot of other things that we can say about these triangles now that we know that the triangles are congruent. We can actually say, well, maybe this angle down here and this angle up here, maybe they're congruent. Well, sure, I didn't need to prove that, but at this point, I can. I can say angle DEC is congruent to triangle or to angle ABC by cpctc. I can also say this side of the triangle. Now, not the whole line, just from here to here. I can say ED is also congruent to AB by cpctc. All of these things are true. And this is going to become very important when we start talking about quadrilaterals, when we start talking about moving on down. Because here's the thing, folks. The whole point of all of this proving stuff is that you can put together a logical argument. And just like Euclid, he started with just his 5 postulates. And we took those 5 postulates and we started talking about lines and points and planes. And then we started talking about parallel. And then we started talking about equations of lines. And then we started talking about perpendicular. And then we start talking about points that bisect and things that are midpoints. And then we went and we took all this stuff and we put it into proving side, angle, side, 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 angle, side, angle, 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 side, and hypotenuse, leg to get triangles congruent. And the reason we want triangles congruent is because that even in a complex shape, like a hexagon, we can take that shape and we can break it into triangles. And if I can use triangles to find all sorts of crazy things, then that means I can find all sorts of cool stuff. And what happens is what was something very small and simple gets built up and built up and built up. That's where we're headed with this stuff, folks. If I take a look at the 2 proofs that we've done today, they're not short. And what they do is they require you to be able to step through logically, piece by piece by piece. This is what's expected of you. This is geometry. This is something that we're going to have to get good at, but it is going to take some practice. To do that, though, you're going to have to know all your definitions. You're going to have to know all your properties. And the reason for that is because it's going to build on up. All right, with that, we will move on to something else.